So let's get started.
Yeah, and just like a last question, like,
Yeah.
and you can work for 3 years.
Yes.
After this without.
So you have to find a job within the first year, and that's the first OPT, and you can extend it for another 2 years. So in total, it's 3 years.
And here they can help. They help you, of course, to find a job. They help you for the internship.
Yes. Yeah. And also we have info sessions. So companies come to our department every week.
Every week?
Yeah,
like,
almost. I think every week. And also we have our career fair, our own career fair.
When is the career fair?
When?
Yeah, when is it?
I think it's in October, but it's only for our students.
Oh.
So yeah, sorry.
I'm trying to get a data science job.
But don't they?
Nah, they don't recruit for like data science work. Like,
No, I mean business science club. They keep
they
posting
do.
jobs.
I don't know if they do like data science work. So it's more like just
Yeah.
analytics and like high level analytics.
So you want like
Yeah.
like more than more
even
technical,
even
very
though-
technical.
Yeah, that's why I'm taking this class, right? Just like learn these skills and
Yeah. I think it's a very good program.
yeah.
Yeah. You can try it.
I wanna maybe. I'm thinking of applying to a master just to get this like 3 years working here.
Right.
Oh yeah. It's good. Yeah. Okay.
That's fine. Sorry.
Okay. So for the mini project 3, I think I'm just gonna talk about the first function.
Mm-hmm.
So I think both of you guys didn't use the like the vector, like the as_apply function.
Yeah.
I think maybe we can go through that. I think that's easier. Yeah. So just create a file. Yeah. So like that, the idea is similar. So you want to cut the variables based on how many bins you want, right? K bins. So I think I'll just write some code here. Yeah. And another thing is, so you can write a new function within the functions. So that's similar. So so as you can see, if you define a function within the function, it's gonna just be local. So after you run this function will the function inside will not show up in the global environment. So it will be created within the function, and after the function finishes, it will just disappear. Yeah, so I'm just talking about the mini project 3 a little bit, and we're gonna talk about the final project.
Okay.
I think you should hear like x greater than the cutoff of n.
Yeah, exactly. So yeah, so one way to use the vector operators is so remember as apply takes two arguments. The first one is the list you want to go through. The second one is the function. So what this function does is it will loop through the bucket count. It will call the bucket count from 1 to k, and it will generate a list as a result. So like each bucket count returns a number, and but we do it from 1 to k, so it will return a list of like length k.
So the row before the bucket count, can you just explain that function?
Yes. Yeah. So the cutoff is it has the quantile of the x. Yes. Yeah. Exactly. So so let's look at the thing in the bracket first. So x is greater than cutoff bracket n means, so for example, if n is 1, then that means and cutoff 1 is the first element in cutoff. Yeah. So x greater than cutoff n means everything greater than the first element.
Second, 2, 3, the second, third, fourth.
Yes.
Okay.
Yeah. And so this operator is AND. So it's just a logical AND. And it's similar. So this is this extracts all the elements that is less than the second in the cutoff. So it just returns the whole thing in the first period. Yeah. And length is just the length of the list. So this one basically counts everything in the first bucket. Right. Yeah. So and similarly, we can do it for defaults. So bucket defaults. So here I only changed the length to sum. So defaults sorry, just wait a second. Oh yeah, here should be outcome. So again, we index everything that belongs to the first bucket, and we extract everything. So we index. So this is the indices, and then we get the result from the outcome column. So outcome, remember, is just 0 and 1s. So this one returns 0 and 1s that belongs to the first bucket, and we use the sum. So sum means if it's 1, then there's a 1 default, and if it's 0, then it's nothing. So the sum just returns all the defaults. So this is basically the count, the default count.
But I didn't get like the inside the index. Okay, this is great, but
yeah. So you mean the bracket?
Yeah, the bracket.
Yeah. So oh yeah. So when x so in the bracket, it's gonna be either true or false, right? And it's a list of length x. So it means
it's
for each
gonna
element.
iterate like
Yes.
in
Yeah.
every.
Yeah, every element in
every
X.
element in X.
Yeah.
And
So
if that condition is true, it's gonna
it's gonna be true. And if it's
Okay.
false, then it's gonna be
it's
false.
gonna then someday true.
Yes. Yeah, and then outcome. So if we index that to the outcome, it will just return everything in the bucket. Yeah. So.
Sorry, quick question.
Yes.
So the function has n as a parameter, right?
Yes.
The bucket count function has n as a parameter. So that gets passed in from.
Yeah. So
as a
actually,
parameter.
n is here. N is passed.
Anything you want. Okay. Okay.
Yes. Yeah.
And right, I mean, I understood this part, but what is the quantile? How does that work? Because
Oh yeah.
Yeah.
So this function is like a default function in R. So it just returns. So for the X, it's a column, right?
Okay.
So. How to explain? So like by default, it will just return 4 quarters. So from 0 quantile to 25th quantile, and 25th to 50th.
Yeah.
Yeah, so on and so forth. So it will just cut the X into 4 buckets.
4 buckets. Okay.
Yeah, and here the sequence. So, but you can change the number of buckets.
Oh, okay.
So this is the props. Props does that. So sequence from 0 to 1, and it increases by 1 over k. So let's say if k is 10, so increase a tenth each time. So it's 0, 0.1, 0.2, 0.3, 0.4 until 1.
Okay.
So it's gonna create 10 buckets.
Okay.
Yeah, so that's what it does. Yeah.
Okay.
It's good. Okay.
Yeah.
I think then everything is similar, so you can just calculate the probability of default. So. Yeah, so this one, since we've already count the number of cases and the number of defaults, so we can just divide the default by the count, so which is a like probability proportion. Yeah, and then we can. Yeah, everything following is similar to what you did in the project. Yeah, we can just return. Yeah, we can just try to run. Sorry, I think I have to download the data. yeah, so we'll return the probability of defaults for each bucket. So in this way, because like the supply function is much more efficient than for loops. So if you can do supply, you can just do it instead of for loop. Yeah. For your final projects or something.
Maybe share the code with us.
Yes. Yeah. Yeah. I think I'll do it after the.
Yeah, that's
Yeah. I'll save it first. Okay, so yeah, so I think that's good. So now we can focus on the final project. So there's a sample modeling file under resources. Under the project help, you can. So it's called sample PD model estimation session. It's a PDF file.
Yeah.
Yeah, so you can just download it. We're gonna go through it today. I think go through most of it.
Which?
It's the project help.
Oh, project help. Oh,
The yes.
oh, okay.
So this file basically has a very simple workflow for you to practice. I think here maybe we want to look at the data first. So yeah, maybe you guys should download the project data. Yeah, so if you look at the first line in the PDF file, it's n row, so it just calculates the number of row of the data set. So we can do it here. Yeah, so as you can see, it's 40.
I think we have like different data because it's called FinTech 2018 case.
Yeah, no, I think this is correct. Yeah,
Oh.
yeah. So yeah, so it's 457,000. So it's a pretty big data. And then if you want to look at the number of rows, so sorry, number of columns. So it's 117. So there are around 115 features you have. So yeah, so like the idea for the final project is you want to select only useful features instead of using everything. And also we can look at the head of the data to see, to just have a big picture of all the features. So head just returns the first 5 rows of each column. It's a little bit messy, but I think So you can see the IDs are not relevant. The default date. So this is rep date. This is report date. Oh, by the way, there's a Excel file in the same folder that has the dictionary. Yeah, you should go through that at the beginning, I think. So yeah, so basically these two columns, using these two columns, we can calculate whether the bond is default, and whether a bond is default within the same year in the of the report date. And the other columns are just features that you can use. Yeah. Yeah, as you can see, there are some columns that has multiple NAs. So I think, yeah, at the beginning you can just delete them maybe, because it's useless.
So would you say we should use columns that have actual all values, right?
Not like maybe not more than 90% are valid values.
Okay.
Yeah.
Because we have like 100 columns, right? So I'm just thinking, instead of like chasing down those that have NAs, we can just go with the ones that have.
Yeah, I think so. Yeah, but like even like useful columns, I think there are more than 90 columns that have all the data.
Right.
So you still have to choose.
Okay.
Yeah, important columns. Yeah.
How do you like see the data set in the viewer? Like, how do you like?
Oh, click the bar. Yeah, so it has everything.
Yeah, so if I click on this,
Yeah,
it should
you'll
open.
be here. Yeah.
Yeah, but this one takes some time because it's
Yeah.
big. Yeah. Yeah. So.
And can you just open it in R or any other software? Like,
You mean the .R this?
Yeah.
I don't think so.
okay.
Yeah. Usually, what you can do is you create a CSV or Excel file.
Okay.
So that's readable in our every software. Yeah. I think this one is like specially designed for R, so it's a quicker to load. Yeah. Yeah. Then let's go back to the file. So yeah, so you can calculate the default date after the report date thing. So let's just do it. So let's just make sure it's loaded as date instead of string. Yes.
Do all of the rules apply, like, for the code, for the project? Do we need to comment our code and do all the extra stuff, or we just need to?
You can do whatever you want.
Okay.
So for the final, as long as I can run the code from the beginning to the end, and yeah.
Then if we're gonna take off points for like no comments.
Oh no.
I
I know,
know,
man.
yeah, I don't know what the code is gonna be. It's like 100 lines. Yeah. And comments everywhere.
Alright. This. Yes. Okay. So yeah, so as you can see, most of them are NAs, because like defaults are rare, right? So yeah, I think this is another challenge in your final project, because the default, I think there are only 5% of defaults of all the records. So, but ideally it should be 50-50, so that your model can be more powerful. But in this case, I think maybe you should find some like smart ways to improve your models, maybe a little bit. Or you don't need to. So like just one thing to notice, yeah. Yeah, so here we can change. So yeah, so you can create a default. You can just create a like an indicator column that says if the default is within the current year of the report. So instead of NAs, so basically you want to change NAs to zeros, and change those days into ones if it's less than 365. Yeah.
I think because it's only dollar and days.
Yeah. Okay, so
Because here here dollar days without two default. Because
Yes.
you define
yeah,
it
yeah.
as only days.
Yeah. 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 It's great.
Share these.
Yeah, so here, okay, so there's still other names. So we can, I think there's some. Okay, so yeah, so this is our all pre-processing. So it changes to 0 names. I think we can do it manually. So if you, okay, so here, yeah, so we can just change the names to. I think this is too much. I think we can do it. So there's a function called is.na, so it returns true if the untrace NA if it returns positive elsewise. So I think this is a common trick for you guys to use. So it just slices all the NAs, and you can change them into 0. So yeah.
Okay, and if it is 1, so it's occurring within the 1 year.
Current year.
Yes. Yeah, let's count. Let's see how many ones there are. I can just. So yeah, so there are only 386, but there are like 457,000. So it's less than 1%. So yeah. So yeah.
Wait, so
Yeah.
this is like 2/3 of the data, right?
Yeah.
This is 450,000, and
Yeah.
you guys have 200,000. Is it possible that most of the defaults are in the other, or you guys measured it kind of?
Yeah, I think we sampled it randomly.
Okay.
So I think there are 20 years of data, and we just sampled them randomly. I think that's what we did.
Okay.
Yeah.
I'm just wondering if the other set has. Like,
Yeah, the ratios are similar.
Similar. Okay.
Yeah, just
Gotcha.
1,
okay.
2%. Yeah. Yeah, I thought it was 5%, but it's even less. Yeah.
How can we build a model off of this then?
Yeah, but I remember, in this project, the simplest model returns a very good result, so you don't have to worry about it.
You said the simplest model.
Yeah, returns a very good result. So I think that's reasonable because when a company is gonna default, so maybe their ratios are very different from other companies' ratios. So even though the defaults are only 300, but I think they have like a very specific patterns. So that's why the models perform very well, I think. Yeah, you can try. I think we're gonna try it soon. Yeah. Okay. Yeah. So and and also you can create your own variables, like your ratios you want to use, instead of traditional ones like ROAs, ROEs. You can be creative here. Yeah. And those features can help you increase the accuracy of your models. Yeah, we don't. Yeah, you can transform log. You can do whatever you want.
I mean, like, we have like 117 columns, isn't it like enough? Like, we need to create more.
Like, so I think the first step is you want to decrease the number of variables, but after that, I think you're gonna reach a threshold, like you cannot increase your AUCs anymore. So after that, you can come up with new ratios to see if your model can improve even further.
Okay.
Yeah. It's all optional for you guys. So yeah, remember a very important function is called summary. So we just tell you the distributional. Let's just try one. ROC. Oh wait, yeah. So yeah, this is a very good. So yeah, so this one is most likely to default, right? And also I think you can plot, let's see, So like plots are very useful for you to understand the data.
Sorry, this might be taking us back, but
Yeah.
how could you tell that it's most likely that's ROA is return on assets, right? I think.
Yeah.
Yeah.
So it's very negative.
Okay.
That means it's pretty likely to default.
But what is the firm which is like, which one is it returning, like for all the firms, or like?
Yes. Yeah. So this function, yeah, this is for all firms. So it just calls the ROA column,
Okay.
and it returns the summary of the whole column. So it's every company in the past 20 years, and the minimum value is negative 191, and the median is 1, which is normal.
Okay.
Yeah.
I'm still a bit confused, sorry.
So ROA, so we can, yeah.
Oh, yeah.
So wait, it's ROA is return on assets, it's a value.
Yeah. So it's negative, so like they have losses.
But there's also the maximum is like plus 273, right?
Yeah.
One of the firms is 273 and the one of the firms is like minus 190.
Yeah.
So what we have to do is we have to separate them out. Like that's the whole point of merging. Like, we have to separate out the ones with the very bad ROA in one bucket and these ones, the positive ones.
As
like,
we did
should
in
be.
the mini project, this mini project 3, I think.
Yeah. Yeah.
Or
Yeah.
I guess you said there's a high probability of default, right? But there's also a high probability of non-default, right? At the same time?
Yeah.
Okay. All right.
Yeah.
That's-
So
I guess
I
that's
think
what-
it was a little bit confusing. Yeah.
Okay.
Yeah. After you put them
It's not like
into the
one-sided,
model.
it's
No, no, no.
one-sided.
Oh, yeah.
It's equally
Yeah. It was just giving you all the summary details for all
I
the
see.
columns. So
Yeah.
what was the minimum, what was the maximum, what was the like median and stuff.
Yeah. 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 So you can, as from the plot, you can see most of them are around ones, and there are some large ones, some negative ones. And I think there are other plots. So you can explore the plot function. There's like a box plot. I don't know if you guys, box plot is very useful to detect outliers. So something like this. So 1, 2, 3, 4, 5 here are 5 features. So for example, here is ROA, and this one is the median of the of the data, and these two are this one is the 25th percentile. This one is the 75th percentile, and
minimum.
yeah, actually that's not.
Minimum.
So it's like this one is, I think it's 1.5 times this range. So yeah, so the 25th percentile minus 1.5 times something. So basically, this range means the normal range. And if there's a data set out of the normal range, then we can consider it as an outlier. So when you deal with the data, so we'll clean the data, you can just extract this data point to see what's going on with this point, whether it's actually this low, or whether there's a misinput or something. So like outlier detection is a very important part in the data cleaning. Yeah. Okay, so yeah, so similar. So yeah, this. Yeah, I think we can create a very simple model. Yeah, there are some other methods to detect outliers, and there are some statistical methods to deal with those outliers. For example, there's one called winsorization. So basically, it just replace those outliers with it just replace those numbers with these numbers here. So
So
yeah.
you're limiting your data set
to within this range. Yeah.
Okay, so we don't need to ignore it. We have to adjust it to the
Yeah, you can do whatever you want. If you think that's an actual outlier, you can just delete it. So,
could we do this to our data?
yeah, you can do. You can try different methods and see if the model improves. Yeah,
Okay.
yeah. Yeah, I think this is okay. So yeah, let's just move on to the modeling. So I think we can do two models today. One is the very simplest linear regression. The other one is this one, the logistic regression. So we can do linear first. So fit. So linear regression is just LM, linear model, I think. Okay, so this one is very simple. So it's just a default flag. We just set default flag as the y, the target variable, and ROA as the x. So just a one single variable linear regression, and then we can call summary. Yeah, again, summary is a very useful function. So yeah, so if we look at the coefficients here, the ratio for the ROA, like the slope for the ROA, is this one point negative 0.002, right? Yeah. So and yeah, most importantly is here. So you can see this is the p-value. The p-value is very small. That means ROA is very useful to predict the default. Yeah. Let's see if we plus. Yes, if you want to add other variables, you can just use plus here. Let's do it. Okay, plus ROE. So yeah, as you can see, both of them are important. Yeah. Let's try some other columns. Let's see if this works. Okay. Yeah, usually, so the dot means every column in the data set. Yeah, another way. So when you exclude the columns, you can just subset the original data set. So let's sub one.
Just here subset. instead
Oh
of
yeah,
here.
sorry. Yeah. Let's choose another one. Maybe deep eye. I don't know.
Just
Okay. So the dot now works.
Yeah, there are just too many parts.
Yeah. So yeah, there are only I've subsetted
Yeah.
4 columns, and using this as y, the other 3 as axis.
Yeah.
So, yeah, and now as you can see, the first 2 are significant, but this one is not.
Yeah.
So in this case, you can just delete this feature, or yeah. And another trick is you can multiply those. Say times. So the multiplication means we will have both 2 columns, also the product of those 2 columns.
Okay.
So this one is actually called the interaction terms. So you can Google it. So it's useful to improve your model a little bit. So yeah. So as you can see, now these three are all useful right now. So let's see if we don't. Let's see if we don't know. Yeah, so if we don't use the multiplication, the DPI is not useful, right? Here, because the p-value is very large. But if we use the multiplication, now everything is useful.
Maybe because ROA is useful, that's why.
Yeah, but here, like this one is the same. This one becomes useful.
Okay.
So sometimes, because those features have correlations, or I don't know some. So if you multiply them, their like correlation can be found in your model. So you can try multiplication or like a division. I don't know. Let's see. So yeah. So this is basically you want to create new features. Okay, works. Okay, what? Oh, that's interesting. So, what? Okay. Okay, so this operator, instead of doing the division, it actually it just excludes the DPI, but keeps the other 2.
Oh.
Right. Yeah. So I think maybe if you want to do the division, you have to create a new column, which is this one divided by this one, and then you put it into the model. Yeah. So, okay. And yeah, let's use the logistic now. So the only difference is this is GLM, which is generalized linear models, and you have to add a link. You have a link as logit. And that's so yeah, this is similar, but like a logistic can output the probabilities instead of the whole range. So yeah, I think what I suggest what you can try first is the logistic regression for your project. You don't need to try the linear regression.
Oh, this one. So GLM.
Yes, GRM with link logit. Yeah. Yeah. Another thing is here. It has an NA action, so sometimes there are some NAs in your columns, right? If you forgot to deal with them, you can still say something here. So this one means if there's an NA, it just delete it. It just doesn't include it in the model. Yeah, but you can have other methods. You can fill in the missing data with means, medians, whatever you want, and try the result. Yeah, this is okay. Plot. Okay, so you can also plot. I think it's a little bit slow. Yeah. Another trick is when the program is slow, you can just use a very small subset to do those models or to do the pre-processing, so it can speed up a lot. And after that, after you have the workflow, you can apply it to the whole data set. Yeah, I don't know why it's not working. Yeah. I think another thing Lad mentioned is at the very beginning of the project, you want to split the data set into training and validation, two data sets. So you use the training data set to fit models like this, and then you use validation set to validate your trained models to see whether there's a overfitting or like underfitting, something like that. Yeah. And also you always want to show the ROC curve and the AUC using the validation set, yeah, instead of the training. So I think the model is too large, so it's pretty slow. So. Yeah. Great. Yeah, and let's say, so now you have the models, and you want to test them using your validation set. So you basically want to predict the probabilities of your validation set. So I think this should be the, okay, so like when you call to plot the model, it will return some statistical plots. I don't know what this is. Also, yeah, so it's predictive. I don't know what it is. I think there are some residual plots. Yeah. So you can just play around with it. So, let's see what it is. Yeah, I don't know why the computer is so slow. Number of times. Okay, I see. So yeah, so the fitted values, I think it just returns the probability of default of each record. Yeah, I think this is not. Yeah, and also I think when you go back home, you can check those histograms. So yeah, remember again, when you do the presentation, those plots are the most useful ones instead of the results. Because so from my experience, everyone's results are very similar, and except some students have visualizations and the others don't. So, yeah, and then you can draw the ROC plots using the CA tools. I think that let's just do the prediction. Yeah, so here are plots. First. Oh yeah. Yeah, so the prediction is just predict. And this is the model. So it should be fit 7 here. And the data set, so you have to create a new data frame to predict, to generate predicts response. Yeah, okay. Yeah, I think before that. So we may want, I can show you how to split the data set into training and validation. I think it's also mentioned here. Yeah, there are lots of ways to split the data set. I think this is just one example. So what this does is, so this one is random uniform distribution. it just creates a random number between 0 and 1. And so here it creates the number of rows, like, so it's 400,000 0 and 1, like a decimal numbers. And we want to see if the number is less than 0.7. So like on average, there should be 70% of the data that's less than 0.7, and there should be 30% of the data is larger than this one, because it's uniform distribution. So in that way, we can just let's just count. Yeah, so it's like 69.9%. So, and then we can just slice it. Train data. So the comma here means we extract every column, and this is the row index. So yeah, so after we run this, you can see we have created another data frame here. So it has 320,000 rows, and similarly we can do it for valid. Valid. I think I'm not sure. Okay, maybe it's not. Sorry. I think should be okay. Oh, yeah.
You have to rerun the training data.
Yeah, great. Yeah, so in this way, we've created two. And let's retrain the model. Yeah, sometimes, so like the default should be 70%, but sometimes you can set it to 80, 90%, that's fine. But sometimes you have to be careful that the validation set has at least maybe 20 defaults. Otherwise, if there's no defaults, then I think it's not very useful. Okay. Yeah, so predict. Okay. Okay, we can summary. Okay. So now we just prediction of the validation set. The mean. Yeah, so it's expected, right? The mean is very small. That means most of the cases, the company will not default. But there are some, like, from the max is 1, so that means some companies are predicted to default 100%. So, and also we can compare it to the actual default or not flag to see our accuracies. So you can set like a threshold whether the company will default or not. So we can just set it to be 0.05. If the probability predicted is larger than 0.05, then we set it to default. And if the probability is less than 0.05, then we can set it to non-default, to 0, basically. We can use the if else. I think that should be fine. And then we can compare it to Okay, that's good. Okay. What?
Why it's not like that?
Yeah. I think it's. Yeah. I think that's crazy. Okay, so I don't know. Yeah, so I guess we have a very good model. Yeah.
Project is solved.
We just need to spruce it up.
Yeah. I don't know. You can try it home. I don't think it should be that high. I'm not sure. So this is the very first example, and then you can try other combinations of those features, and you can create your own features.
But we had 400K.
Yeah.
But now it's 137.
Yeah. So we use a part of it to train the model, and the other part to test the model. Because if we test our model on our trained data, then that will be actually cheating, because we train the model using our trained data, and we want to test it. So basically, if you train perfectly enough, the accuracy could be 100%. So we want to try the model on another data set to see the stability of the model. Yeah.
I think if you go to fit, probably did you retrain it?
Yeah, but it's trained.
did.
Yeah, it should be correct.
Yeah. Because earlier you used the whole data set. Right?
Yeah, yeah.
So
Just be very careful. If you use the whole data set,
that
would be also actually cheating a little bit.
That might be the reason why it's.
Yeah, maybe let's do it. But I think I remember I did
think
it.
so.
Okay. So I think there might be something wrong in the code. Otherwise, it will be too perfect. I remember I got. I don't know. And also you need to look at the AOC curve, the ROC curve and the DAOC, because I think.
Yeah.
Yeah, let's see.
This would be perpendicular, man.
Maybe. What's the function again?
Call AC.
Call.
COL, I think. COL, right?
Well.
COL.
Oh, yeah.
AUC. But AUC is like uppercase.
Oh. Okay. Is this correct?
And then you have to plot ROC.
Oh,
That's another.
so we. There's a. What's the function? So just plot RE.
Yeah, it's.
Okay.
It's just.
Oh, got it.
It did plot.
Yeah, it should be. So the first one should be the probabilities. The other one should be zeros and ones, right?
Yeah. X is the matrix frame and Y is response.
So shouldn't this be the first one out dot predict?
Oh yeah. Okay. What? Same thing. Yes, here it's 91%.
It's giving you.
Yeah, it's 91.
Yeah, but the plot is just
Yeah.
giving you a random.
I don't know. Let's see what he did, what he used. Same thing. What? ROC? Liquidity.
you get the look at the curve. It changed.
Oh, got it.
Yeah.
Got it.
Now
Yeah.
it looks like the perfect.
Perfect.
Yeah, 91 is
Yeah.
it's okay. But I remember last year there was, I think the highest was 95. I'm not sure, but it's much. I think it's definitely higher than this one.
Okay.
Yeah. So I think that's why we use the ROC instead of accuracy. Because I think like 99%, more than 99% are non-defaults.
Yeah.
So if you predict non-defaults for everything, you'll get more than 99% correct.
Yeah.
So like accuracy is not very useful in this case. Yeah. So you guys should use ROC. Yeah. But I think this is a very good model already. Yeah. You can. Yeah, I should use other features instead. Yeah. So yeah. But like, cause it's a competition, right?
Yeah.
So like, which one gets the highest will get 10%.
So we don't need to like have decision trees and all that.
Yeah, you should. You can try decision trees, and
How can we do
you can. I think there's a package, but I forgot. You can just Google it. Yeah. C-tree. Yeah, you can just try. I think it should be similar. Yeah, like the formula. Only the difference is the function, so you can try it. Right?
So we do it instead of the linear model?
Yeah.
Instead of the regression, I mean?
Yeah. Instead of LM, you use C-tree here, and there are several other packages that's used for decision trees. You can try some of them.
So you think like to have a better model we have to
Yes.
use?
And also I think we're gonna grade you based on the workflow you've been using. So not necessarily depending on the accuracy and the likelihood. So if you try multiple models, you're likely to get a higher grade. Yeah.
Okay.
And there are other models, I think. Gradient boost. So it's another tree you can try. So you can, if you have time, you can try everything. GBM. It's I think it's another tree model, but it's a more advanced model. Yeah, and for linear. Yeah, I think for logistic regression, there's not much you can do except you can create some new features.
But we should at the end choose one, right?
I don't know. Yeah, you should choose one. And then actually, there's a more advanced method that you can combine the results of different models. It's called bagging. This is very easy. I don't think there's a package. Oh, is there? Yeah, you can look into that. So basically, what it does is you create the probability from two models, let's say, and you combine those probabilities somehow. So you can set weight. So for example, if you use logistic and tree, you can set the weight of the logistic outputs to 0.4, and you can set the weight of the tree to 0.6. So it will combine those probabilities into another one. And usually it will perform better than each one of them. Yeah. Yeah. I think. Yeah. if you can do all of this, you'll be great. But if you do only the simplest one, that's enough actually. Yeah. But you will not get a bonus. So yeah.
So if we just do this, like how
Yeah, I think this one
we
is
get-
good enough. Yeah.
we'll get like maybe like a B plus.
Yeah, I think so. Yeah. So, but yeah, but don't quote on me. So, but it's better because when you try like you will add like maybe 2 other features, the AOC will get better. So, yeah.
But here, like, how are we gonna choose like which like
Yeah, I think,
variables to use? Like we have 117 column,
Yeah.
117 variables. So
Yeah, I think there are 2 ways. The first one is you can just try everything. The second one
try
is
everything like alone, like.
either alone or you can put maybe 50 in one model, and you look at the p-values.
50 and we add them like plus.
Yes. Yeah.
Okay.
Yeah. And the other way is you can just like use your knowledge. I was like those ratios, which should be reasonable to put into the model. So you can just choose maybe 20, and then you can select, you can delete and do whatever you want. And like in the final model, it should be around 5, but it should definitely be less than 10.
Around 5 variables.
5 features
Okay.
Oh,
like
so,
ROA, ROE.
okay,
something.
just 5.
Yeah, ideally.
But you have to select it from 117.
Yeah.
So,
Yeah, and another thing is, even though you get like a 91 in the validation set, you may not get a very high result in our test set. So you want to make your model basically as simple as possible, because maybe you can get 95 here, but in our test case maybe you can only get 88 something. Yeah. So that's why you have to keep it to 5 variables, so it's more stable.
But if we use the backend function that you spoke about, would that help when you test on your data? Or
From my experience, yeah, it will.
And
Yeah,
you
yeah.
can combine like only 2.
You can combine like
Okay.
whatever, like 10. Yeah.
Okay.
You, as long as the weight adds up to 1, then it's fine.
And how
Weight
would
of
you
the
choose
data,
the
right?
weight?
You can choose it like you can test it, so you have to do it manually.
Okay.
Yeah. So
So
what was the
it's-
question?
It's how you split the data. The weight of the data should add up to 1, and
No, like
some part of the data you are using one method, and some part of the data you are using the other method. How is it?
actually, yeah, it's you want to use all of them, but so like it will create a probability, right?
Yeah.
So, but you want to set a weight to that probability,
Okay.
and the weight, those weights add up to 1. So let's say if you think a logistic is worse than decision tree,
So it's gonna
you can
be
you can set
close,
0.2 to logistic
Okay.
relation and 0.8 to the decision tree.
So okay.
Yeah.
So
In
the
your
first-
model, you are going to calculate the probabilities using all the methods, and then add them up
Yeah.
using the
The weighted average.
weighted
basically.
average, and then the combined thing is what your model is going to
Yes.
put. Okay.
Yeah. Yeah.
Okay.
Yeah.
Okay.
Okay. I think that's pretty much.
It's like I assumed it was more complicated.
Yeah.
Yeah, cause
Now
'cause
it's more like.
like a practice.
Yeah.
Yeah, cause the data is pretty ideal, I would say. Like in the
Yeah,
real
I-
world, it shouldn't be like this.
Okay.
Yeah.
I feel like the mini projects were more challenging. Like, yeah.
Yeah. Yeah. So this one is all about modeling
Yeah.
instead of like coding.
Yeah.
Yeah.
do you have like PowerPoints from like the last like other presentations that you can share with us?
Your
I think it's from their. You should ask Professor Stein.
Okay, just to know.
I don't have them.
Just exactly.
Sample.
Yeah. Yeah. I think.
Should be included in the
Yeah,
code
yeah.
one,
Yeah. Yeah, the project is not very challenging, I would say.
Yeah.
Unless you want to get the number one, like the bonus. Yeah. And also,
can we have like a one? Is it like, can we get an AUC of one?
no, no. I think at most you can get 96.
Okay.
I don't know. Yeah. Yeah, if you can get 96, you don't have to do anything else. I think that's good enough. Yeah. And yeah, I think that's. Yeah, also I think you should look at the likelihood. So the ROC is the power. Right?
Yeah.
Likelihood. I think likelihood is in the summary. I don't remember very correctly. There's. I think.
And the report that we submit, how big is that? Is there a sample, like, just follow the instructions or what?
You mean article?
No, I mean,
The presentation.
not the presentation, we have to submit a report.
We don't have a report.
No,
No?
just a presentation.
Oh, okay.
Yeah,
Mhm.
yeah,
Just the presentation and the code.
And the
Yes.
code. Okay.
yeah. Likely. Yeah, I think the likelihood. Yeah, I think you can test the likelihood on your own. So you're gonna predict the probability, right? How to do it? Yeah. Not usually. Yeah. Sorry. Let me just Google it. I think there's a lot of likelihood for the model. I don't know. What? Yeah, so there's a package. Yeah, so you can Google it. But yeah, so the idea is not you should focus not only on the AUC but on the likelihood as well.
Okay, so how do we measure the likelihood?
So there are packages.
Oh.
Yeah. You can explore it. Yeah, and yeah, in your like presentation, ideally you should report both AUC and likelihood.
Okay.
Yeah. Yeah, I think. And also the accuracy, although it's not very relevant. Yeah. Yeah, I think that's pretty much it.
So the likelihood is, it's not a curve, right?
No, it's just a
It's
number.
just a number.
Yeah. Yeah. Looks easy.
Yeah.
Yeah.
Because it's like 6 pages, and I thought it's gonna be.
Oh, okay. Yeah. Yeah. Okay. Any